Hello, in this screencast we're going to open up an intracranial EEG. We're going to create intracranial montages, both for review and for trending, and we'll do spike detection on this recording as well. This is Michael Guest, VP of Research and Clinical Applications for Persyst. Let's get started. And one of the things I did in preparing for this, since I had already gone through and done some work on this recording, is I removed some of the trend results and spike detection results so we can have a clean start on that. And just thought I'd show one of the features that can be handy in P14 revision D or later. All these instructions apply to Rev.D or later. That includes D1, D2, D3, and so on. P15, however, will have an even more streamlined approach to generating intracranial trends and detection. So with that said, let's go ahead and get started. This is a recording I'm going to use, and there's a right-click option where we can for instance, browse directly to the folder that's at, and these recordings are here. I've already removed some of their results files and so forth. Now you can clear results from the GUI in Persyst, hitting the X, but this is the file that we're going to be working with. So that's one way to get directly to a folder. And you can open recordings from the database, which allows you to leave it open while you open any number of instances of Persyst. Well, we'll just launch Persyst 14 from the desktop here. And we're going to open the recording. And again, this process that we're going to be going through, this just goes through processing and recording in Persyst offline. This happens to be in Persyst layout format. If you're doing this within an OEM EEG system, some of the instructions may be specific to that as far as how Persyst is integrated. And if you're doing it online, of course, that is definitely dependent on several things within the OEM integration that can vary from system to system. So in those cases, let's go ahead and web conference and go through some of those specifics for that. But in this case, we're just going to be looking at a recording offline. Now this has the P14 scalp trends loaded. Obviously that won't work for a intracranial EEG. And so let's go ahead and change some of the settings here for our purposes. 7 microvolts is going to not work for this, so let's go ahead and set it to 70. And one of the things we can do is we can take a look at some of the channel labels just to give us an idea of what we're going to be looking at as we build these montages, because everything starts with a montage in this case. There's an all button here, and I can reduce the number of channels displayed vertically. And so if I set this to 32, there's 32 displayed on the right, where are the other channels? They're displayed below this. And there's a scroll bar here. Now you can drag this, but it just bumps it a few channels at a time. If you want to go full page, just click in the blank area either above or below that scroll bar, that thumb bar as they call it. And we can see we have unused channels here. They're C labeled channels, so some systems use C as the unused or as the default label. And these other channels happen to be labeled according to whatever was in the particular channel map. So with that being said, let's go ahead and create an intracranial montage for this. And I'll just show the EEG full page, and we'll go back to our all to show all the channels here. So we'll go to the montage dropdown and then select create intracranial montage. Now this assumes that you've already set a location for those intracranial montages to be saved. This is what the dialog looks like. This is the patient name that was entered for this particular recording. Obviously, it's not the patient's actual name, and it provides a date after that. You can stay with that format, or you can change it. This is fine to edit. I'm just going to shorten this up a little bit for the purposes of this. And I already looked and saw that the C label channels are unused, so I'm going to go ahead and hit the trash can to remove that. Now there are other features here, left, right, lateralize. There's items in the settings where you can set the hemisphere, you can identify the default spacing, you can set colors. These items in the middle really have more to do with the intracranial, the Persyst imaging workflow, where you can use a semi-automatic process to take CT and MRI, you can co-register those images, you can look at the imaging to see where the electrodes appear, and then generate maps for those to show them in a graphical format. We're not going to go over that in this particular case, but that's what these middle pieces are for. Same thing with the type of electrode. And if we go to the settings here, This is where you can identify non-EEG channels. You can edit the laterality naming rules, how it's prefixed, and so forth. And you can also say the default number of channels per trend. And if we look at some of these, they have multiple channels beyond 7. So we could break this up. If this is a grid, then we could go ahead and modify that. And also the rows and columns will affect, depending if you want to have bipolar pairs assigned within rows, columns, or both, you can assign the geometry here. I don't have the geometry of this particular recording, but we'll just go ahead and put in some numbers here that will add up to the number of trends that we have. And so once we've done that, and the channels per trend, this again will create multiple trends for instance, for this LOF group of channels, because we've set channels per trend to that. So this can be modified to decrease or increase the number of trends per group of channels. Let's just go ahead and create the montages. In this case, those are the names that it'll give. It's going to create 2 bipolars and 2 referentials. We'll see what those look like. And this is where it asks us to do bipolar pairs within rows and columns, or just rows or columns. We'll just pick rows for now, and we'll select OK. So now it's created these montages. Now these montages don't go in the standard PS montage templates.xml file that's stored in C program data Persyst. Those montages are usually stored, well, they are stored in a place that's defined when I go to Preferences and General Preferences, and then I go to Database. I've just got this set to my C temp PIW for Persyst imaging workflow. Normally this would be on your file server, so that if you access this from other acquisition system or other review stations, they can all pull up those montages specific to this particular patient's recording without having to recreate them each time. So it's a shared repository for those custom montages. In this case, this is standalone, so I just put it on in the temp folder. But in practice, you're going to assign that to a shared network location. And those montages are available for review. So if I select this, here's my bipolar. What's the overlap? Well, it takes adjacent channels and it overlaps them so that we can see all of the channels a little bit easier. Same thing with the referential overlap. It overlaps adjacent channels, but let's just go ahead and switch back to the bipolar montage. So first step was to go and create intracranial montage, making the adjustments to geometry and so forth based on the patient recording, and then it automatically creates the montages. It also creates the channel lists, and those are essentially groups of channels that will be assigned to particular trends, so we don't end up with 200 trends, which would be very hard to review. We'll end up with a subset of trends that will be trending anatomically adjacent channels as one. All right, so now we'll go to Modify Template. So we've created our montages. Next step, I'm going to pick this IC blank P14D. And again, this applies to P14D or later, any of the numbered increments. P15, again, the process is somewhat different. So this is just for P14D and later within Persyst 14. So now I've opened an editing instance of Persyst. It shows up as a separate window. And in the upper left, it says Modify Template Mode. And again, we've got this bipolar montage we've created for this particular recording. And I'm just paging around a little bit. We'll stop here. Now I'm going to build some trends. And to do that, I want to split the screen. And you can see that we have this IEEG blank template P14D. Now, since this is for a particular patient, what I'm going to do is save this under a different name. So I'm just going to put this in there because it happens to be the name of this file, but you typically type the patient's name, and that's what's going to show up at the top so you know which trend template you're using. And for channels, we're not going to use the recorded montage. That shows all the individual channels, but we don't have any channel groups. And so to show those, I'm going to scroll down and go to my bipolar montage that was created. And here's our channel groups. And so each one of these is an assembly of these channels. It'll average them together and show them as a trend. So now I'm going to do Save As. I don't want to overwrite my template. At the top here it says IC blank P14D. I'm going to do Save As, and You can browse or you can just edit the name here. I'll browse so we can see where they are. They're in program data persist. And this I'm going to call hf2.mmx. And normally, again, you'd use the patient's name here so that it's unique to them. And I've already got use this template to process new records. Well, I'm going to be processing a record with this. So I'm going to select save. And now the name is changed at the top of this dialog where it says Persyst, program data persist, hf2.mmx. Got my channel lists here. Okay. So the next step is to replicate these, and then I'll delete these. This is just a placeholder for this. So I'm going to replicate the trend, and I'm going to select all lists. And now all those lists that were created by the montage creator, it creates trends for those. And I can delete my first placeholder. Now we can also do, because these are going 0 to 60 hertz, we can also do versus baseline trends, where it'll calculate normalized z-scores from a baseline. And what that allows us to do is to see changes across the whole spectrum, 0 to 60 hertz, because it normalizes all the values within that empirical null that's calculated by the baseline. And well, we can get more into that another time with another example. I've also got another screencast on that. Let's just go ahead and create the trend. So I've already created my FFT spectrogram setup. Now I'm going to create the Z spectrograms. And to do that, same process. I'm going to replicate this trend. And instead of all lists, what I have to do is just pick the ones for the FFT spectrogram. So I'm going to go ahead and deselect the event densities. We'll use that in a minute. This is our placeholder. And I'm not going to do this for heart rate or rhythmicity or the other stuff. So these are all the trends that I've set up for FFT spectrograms. And I've deselected the other ones. And the reason I do this Z spectrogram thing first for the spectrogram, FFT spectrograms, is I don't have to fish through as many of trends. I can just deselect the ones that I'm not using. Select OK, and now we have these. I'm going to delete the placeholder from that panel. And let's go ahead and select rhythmicity spectrogram, and we'll replicate this. All lists. OK. Again, get rid of my placeholder at the top. And we could do the Z spectrograms, but you get the idea for that. Let's just start with this. And I'm going to set this as my default display. Go to Preferences, Trend Preferences. Let's save the work that we did. Now, one other thing is if there's a heart rate trend, and we do have an EKG2 here and an EKG1 to ref, you can configure heart rate. Let's go ahead and do that now. So what I did was I selected heart rate just by clicking on the label there, select EKG channel, and this is where I'll tell it to use EKG1 to ref. That should be fine. I see a nice EKG signal there. Actually, EKG2 is a little better. So I'm going to select OK to that and save my changes. Preferences, Trend Preferences, save. And now we're done. So I'm going to close this. Ask me if I want to save changes. Yes. So now I'm back in that original processing instance. I don't see the modify template here, but I've still got the trend template that had been selected when I launched the program. So let's change that. So I'll go to Trend Preferences, select Template File, and there's my HF2 MMX. I'm going to open that, select OK, and now I've got my trends. So we'll go ahead and process. And this is not a very long recording, so we'll let it go ahead and complete to the end of this. Now you can configure the spike detection before you begin processing. You can process the spikes after. It does launch a separate application called Reveal, which is the previous generation spike detector. It's no longer used for scalp EEG, but it does allow processing with any number of custom labeled channels. And so that's the option for spike detection in Persyst 14. And this is almost finished. Actually, I'll just pause it where it is because we could do this configuration anytime. I'm going to click the Tools button here, go to Spike Detection. And I'd already configured an intracranial, but let's start with what it would display normally, which is the default scalp, even though Persyst is deprecated for scalp. That's the default setup. So we're going to go into settings and protocol, and we're going to configure it to do intracranial detection. So let's go ahead and apply the montage first, because right now it's just showing the recorded montage with all the inputs. And we'll pick a bipolar. You can pick a bipolar or referential in this case. So I've selected this. I'm going to change the sensitivity. If it was set to automatic, I want to remove that automatic designation and set it to what you're reading the EEG at. We're reading this at 70 microvolts. So we set it 70. We're not going to use 1020 topology. There is none. And the other thing I want to do is sort by code, because in some channel labels, it'll read the input as either temporal or eye blink channels. Obviously, there's none of that in the intracranial, so these should all say none. And if I scroll to the bottom here, I do see EKG inputs, and I do not want to run spike detection on that because it'll find lots of spikes in the EKG channel. So I'm going to edit selected. I've highlighted these just using shift and mouse select. And these are 3 position buttons, so I just clicked it twice to clear the process. And by the way, there's the setting here as far as non-eye blink or temporal. Doesn't matter because we've turned it off. So that one's done. Now I'm going to go over to the rhythmic burst montage. We're not going to be running the rhythmic burst detection, but we'll go ahead and configure it so it doesn't complain about it not being configured. We'll just configure it exactly the same way. And to do that, we'll scroll down to the bottom, and we're going to disable the detection on EKG 1, 2, and the event. And for settings, I'm going to go ahead and set the sensitivity here a bit higher than the default so that I can use the low, medium, and high selection on the toolbar in Persyst. Not only in the EEG page toolbar, you can change the detection sensitivity after the fact. You can also change it in spike review, which we'll have a look at. And I've also selected store detailed spike information. That's important as well. We want to be able to open this in spike review. So I'm going to close that. I've made my settings changes, and I'm going to save those, save protocol, and I'll call this HF2. So you could call it IC and use it again and again. Obviously, you'd want to change the detection montage for each one. So if you want to use this as a generic protocol for your detection, that's fine. Let's go ahead and remove the notify buttons. We're processing offline, and normally you wouldn't have these selected anyway for Persyst 14. And we're not going to bother with detecting rhythmic bursts. We'll leave spike and spike burst engaged. Let's save those changes. Again, settings, protocol, save protocol. Okay. Now we are ready to process. By the way, this drop down here is just the length of the histogram. So it doesn't change anything as far as the processing goes. And this is where we pick the detection protocol. So that's that IC detect we've just created. Click process, and away it goes. And this runs pretty quick, and we can run both at the same time. I'm going to click the process button on the left part of the trend bar here. We change this from 2 hours. Give us a little closer view. I'm going to set this to 15 minutes, which is really a more typical page length for looking at intracranials, where you can have very short duration events of interest. And you can see they're processing at different speeds. The detector will actually catch up at the end of this processing, but we'll let it go ahead and finish. And it's approaching the end of this file. It's done. So there are the spike indications here. Let's go ahead and pause the detection. It's going to ask me if I'm sure. We'll close that. And we'll go ahead and pause the trending over on the left as well. Okay. So we've done that. And if we click around on the trends, it'll take us to that point in the EEG. We can change gain, montage, and filters, of course. Let's go ahead and look at the spike detections. If I click the spike review button on the left, and right now it's showing a scalp montage, so it's showing a blank. Let's pick one of our intracranial montages. And we'll change the gain here from 10 microvolts. We'll bump that up to 100. And now we're showing in the particular, whatever montage we want to show, the detections by electrode, which is whichever electrode had the highest probability, which tends to be amplitude related mostly, but not always. And each one of these is marked with a particular electrode as the one that had the highest probability of detection, because it detects across all groups. Now these seizures are all continuous spike, so it's picking those up within those seizures. And the old reveal algorithm, which this is, does not attempt to mark all the spikes within a spike burst. It'll mark some subset of those. The current spike detection for the scalp product, or the scalp algorithm, does do that. So just keep in mind, if you're doing spike counting in an intracranial, this is really primarily optimized for interictal as opposed to ictal. But it will mark them within an ictal burst. It just won't mark all of them. And I have a separate screencast on using Persyst to create groups of spikes, but I'll just quickly go through this, and I'm going to go ahead and change the gain here, make it a little bit higher. I'm going to sort by amplitude. By default would be time. Time isn't necessarily the most helpful. If we're looking for exemplars, we're sort by amplitude. And as I'll include in another link, the process is to select an exemplar. And so we'll go ahead and see what we can see for that. I'll pick this one as an exemplar. And then the idea is to go through and then do your spike matching. So I'm just going to randomly click through this so that we can get the idea. Now we go back to overview, and then we pick some other groups. But final report, this is the average of the ones I've selected out of this group. And again, I was just clicking away on the screen, so don't take this as the way to mark this particular recording. And then from the tools menu, you can mark these groups as voltage plot comments. I went ahead and did that. And what happens in the over on the Persyst side of that, now that I've closed spike review, is it'll write at vplot comments to this list. So if I sort it by text, those are the 4 vplot comments that I exported. Again, you can do as many as you want. And if I want to export these, then what I would do is go to Tools, Archive, and I'm going to expand this menu out a bit at the bottom. I've selected at vplot asterisk. It's going to select all of those. If I want to restrict this to a particular group, then I would include the full text of that. So let's say I just wanted group 1. Let's go ahead and close this. I can just use this to copy the text. I don't want the perception values because those will change with each one. So let's just say I want a group 1. Then I can go to Tools and Archive, and I can modify this particular text. Put an asterisk at the end of it. As a wildcard, I'm going to do ½ second before and after, and click Archive. I'm just going to drop this on the desktop as an EDF, but you can save it as CSV values any way that you want. So let's save it as an EDF for now, and it's done. So then archive the ones that are selected as that. If I close Persyst here, there's an EDF recording that I can just drag onto the Persyst icon, open it up. And again, I told it to clip ½ second either way on those spikes, and that's what it picked. So the file is end to end to end. It doesn't make any distinction about creating any space between them. So, but you can pick one spike, or you can pick multiple spikes to archive by manipulating the text of it, or doing it by spike. You don't have to create vplot groups. You could actually just say, well, instead of vplot, I want to mark spikes using the spike comment. So any text will do for that. And that is the process from start to finish of going through that particular recording. And let's have a look at some of the other trends real quick, just to get a view of that. I clicked a little too quickly. I want the one above that. And that'll open up here. So I'll go ahead and pick the montage that I want to review in, and there it is. So one other tool I'll mention for this is looking at high frequency activity. And to do that, I'm going to go ahead and move back in this record a bit, and I'm going to reduce the number of seconds to 5. And if you look very closely on some of these, you might see a little hint of high frequency activity running along on some of these waveforms, but it's hard to visualize that way. So there's a tool to show 2 different gains, filter ranges for each channel so that you can see both the Burger Band EEG and high frequency at the same time. And it's very quick to use, so I'll just go ahead and show how to do that. So I'm going to go ahead and let's do this in the referential just for interest. So to do this, I'm going to go to Tools, Create High Frequency Display, and it's going to give it a HF suffix. By default, it'll do 50 to 150, but of course you can change these filters to whatever you like, and you can create additional ones. You could create infra slow, for instance, just by putting in the appropriate decimal value for the cutoffs. And so I'm ready to create the high frequency display. I'm just going to select OK. And now it's doing an overlay. Let's spread out the channels a bit to see what's going on more clearly. So right now we're looking at 5 seconds of EEG, 24 channels, 100 microvolts for the black traces, and the greenish traces are showing 7 microvolts from 50 to 150 hertz, and it's overlapping them. So if I turn off the overlap, you can see that each channel, so here's the high frequency for 88, and here's 88. And what I'm seeing is the high frequency component that's riding on each one of these spike discharges. I can overlap them, and I can move the slider to fade them in and out, so I can see which ones have spikes, which ones have spikes with phase locked high gamma, and I can page up and down. Not all the channels that have spikes have phase locked high gamma associated with them. And that is also available in Spike Review to look at. So you can pick this montage, this high frequency montage in Spike Review, if you wanted to sort things that way. And if I go back to the bipolar montage, this is showing segments where the EEG was converted into segments for the detection, for spike detection. So we could say that it's a different montage if we wanted to. But in any case, that's the application of that. I don't think there's anything else to cover in this particular video, but if there's other questions that come up, just go ahead and send me an email. Again, this is Michael Guest, VP of Research and Clinical Applications for Persyst. Thanks.